5.6, you need to find all rational zeros. We're used to only having 2 zeros because we're used to looking at parabolas, but now we're going to look at things that are a little bit stranger. In order to find all rational zeros, I'm just going to show you how to do this using a calculator. So plug in this equation, 10x to the 4th minus 11x cubed minus 42x squared plus 7x plus 12 and graph. And we get something like this. That's not very useful, so let's go ahead and press zoom. Well, we can see it crosses the x-axis a few times. Let's go ahead and press zoom fit. And zoom fit just does that, so that's not useful either. Let's go back to standard. And what I want to show you in this lesson is zoom's pretty good, but sometimes you need to do a little bit more than that. You can mess with the window. The window button's right next to zoom. Now looking at this graph, it's a standard window, so it goes from -10 to -10 on the x and y axis. And here, we really want to see a little bit closer what's going on the x-axis, because it's all squeezed in the middle. So let's look at the window. The x minimum's 10. Let's just look at maybe 5. Let's go from 5 to 5 and see what we get. Now it's definitely a lot easier to look at, and we can calculate those zeros. Notice how there's 4 zeros. And you know there's 4 because this is an x to the 4th function. That means there's 4 zeros. Some of those zeros might be imaginary, but for all the ones in 5.6, they're all real. So left bound, we're going to have to go to the left of the first zero, enter, right of it, enter. Looks like our first zero is -1.56. Calculate the second one. Go to the left of it somewhere. And the right of it. Second zero is -0.5. Go for the third one. .6. And the last one. Go to the left of it. Left of it's actually there, and the right of it's up here. And it's 2.56. And once again, if you don't like this window and you want to see a little bit better what it looks like, just change the window up a little bit more. Like maybe you want to see from -3 to 3, and you actually want to see more of the graph. So let's go all the way down to -20 and up to 20 so we can see more of this graph. And it gives you a little better idea of what's going on. We can actually extend it just a little more. I want to see what it looks like at the bottom. Let's try -33, sure. Now we have a really good idea of what's going on. It crosses 4 times. We could have also used this window to calculate the zeros as well. I wanted to show you one more thing, and that is how to do this on paper. And I just want you to take a look at this in the chapter. It's not supposed to be full screen. Let me exit out of there. So how to do this on paper is this really, really long process that I really don't think it's worth learning. But let me just go ahead and show you what you would have to do. So the first thing you would have to do for the same problem is list all the possible rational zeros of that. So you'd have to find all of these. Then you'd have to choose reasonable ones and plug them in. Check them all using synthetic division. Factor out binomials. Repeat the steps. This would take you so long for each problem that we're just going to skip this and do it all with the calculator. Now we're going to run into a few problems in the next section, but if you really listen to the videos and follow my instructions, you're really not going to have the type of problems, but this is what you would have to do just to find those zeros. One more thing you should know really fast is we found some zeros as decimals. Remember our answers were -1.56 and 2.56, and in the book they're going to get things like that. like 1 plus square root of 17 over 2 and 1 minus square root of 17 over 2. But if you calculate those out, it's going to be the exact same value that we have. This one's a little more specific. But on a multiple choice test, if those are the answers, then you're just going to try to calculate those out and see if it matches what you got, basically.